So let's look at these two compounds that we have here. We have K2CrO4 and K2Cr2O7. They both contain potassium, chromium, and oxygen. And what if I asked the question, which compound contains a larger percentage of potassium? Well, this little wheel here, the circle graph, shows me that the K2CrO4 has a larger percentage of K than the K2Cr2O7. So we're going to write that down here. K2CrO4. And what we're going to realize is even though both these compounds have the same elements, there's a different ratio of their mass to their total mass. This has a smaller molar mass, and this has a larger molar mass. And we're going to see why, calculations-wise, why would the K2CrO4 have a larger percentage? So let's talk about what this means. So percent composition is the relative amounts of elements in a compound. The percent composition of a compound consists of a percent by mass of each element in the compound. Let's try to get the percentages found in the first circle graph for K2CrO4. So this is how you do it. If given a chemical formula like K2CrO4, we can determine the percentages of each element in the compound using the molar mass of each element and the molar mass of the compound. And we've done this. We just were able to complete calculations for molar masses in grams and moles. So I kind of already did a little bit of the work ahead of time here and looked up the molar masses of each of the elements in this compound. The molar mass of K is 39.09. The molar mass of Cr is 51.99. And the molar mass of O, of course, I'm going to just write it as 15.999. If you round these, it's no big deal. In this compound, there are two Ks. So I'm going to do 2 times the molar mass of K, because there's 2 Ks. There's 2 Ks. There's 1 Cr. And as you can see that there are 4 Os. I'm going to add that to 1 times the molar mass of Cr. And I'm going to add that to 4 times the molar mass of O. And so if I do this math on a calculator, you might hear me clicking onto the calculator. You will get a molar mass of 194.166 grams per mole. Now, notice how I have separate masses for each element here. In this molar mass of K2CrO4, there is 2 times 39.09 grams of K. That is 78.1 grams of K. There is 51.99 grams of Cr, and 15.999 times 4, there is 63.996 grams of O. And if we add these three numbers together, and let's just double check, let's do 78.18 plus 51.99 plus 63.996, we get our molar mass of 194.6. How are we going to get percentage? And you might see on the next page here, I'm going to take the mass of the element that I have right here, divided by the molar mass of the compound, which is 194.166. 194.166 divided by 194.166 and multiply by 100. Multiply by 100, multiply by 100. If I go and do this math, if I do 78.18 divided by 194.166, we get times 100, 40.2% K. Okay. Let's do Cr. We'll do 51.99 divided by 194.166. If you had to predict, I'm sure the percentage would be lower because the mass is lower. And I get 26.8% Cr. And then finally, if I want to get the percentage of O, I'll do 63.996 divided by 194.166. And I will get, and times 100, I'll get 32.9 percent, which is maybe approximately 33%. You could round and that's okay. One little note, something that we may know already about percentages. The sum of the percentages needs to add up to 100%. You will never guess it, but 40.2 plus 26.8 plus 33 is 100%. And then let's see if we got our percentages from the wheel. Yes, we did. Look at that. They are exactly the percentages from the wheel. Look at the wheel here. We got 40.3% K, maybe we rounded. We got 26.8% CR exactly, and we got 32.9% oxygen. Boom, boom, boom. This is how you do it, okay? So how do we do this? And you could write this down. You could pause, get it right here. We determine and calculate the mass of each element in a compound. So that's what we just did. That's what this step was. We get the mass of each element. That's step 1. Then determine and calculate the molar mass. That was step 2. And then finally, use this equation that we have right here. I did that here, and I did it up here. I take the mass of the element divided by the molar mass of the compound and multiply by 100. And that's going to be the percentage of the element. Boom, and done. Okay? Let's do another example here. Let's calculate the percent composition of propane. Propane is C3H8. That's a fuel commonly used in gas grills. Sorry, that's a typo. Calculate the percent composition. If it's asking you to calculate the percent composition, it wants the percentage of each element in the compound. So that means I need a percentage of C and I need a percentage of 8 because propane is C3H8. So my first step here is I need the mass of each element. Well, carbon has a molar mass of about 12.01 gram per mole. Hydrogen has a molar mass of about 1.008 grams per mole. There are 3 carbons in propane, C3H8. So we're going to do 12.01 times 3. 12.01 times 3, and I get 36.03 grams of carbon. I'll do the same thing for hydrogen, 1.008. There are 8 hydrogens. So I'll multiply this by 8. 8 times 1.008, and I get 8.064 grams. If I add these two numbers together, I get the molar mass. So 36.03 plus 8.064. It looks like the molar mass of C3H8 is equal to 44.094 grams per mole. So we just did the 2 steps here. We did step 1, getting the mass of each element. Step 2, getting the molar mass of the compound. And now I'm going to divide each of these numbers by the molar mass to get the percentage of carbon. Percentage of carbon would be 36.03 grams of carbon divided by 44.094 grams per mole of the whole thing. And I multiply by 100. 36.03 divided by 44.094 times 100. I get 81.7% carbon. And then, side note, rules of percentages, the sum of all the percentages should add up to 100. So 100 minus 81.7 should be 18.3% hydrogen. Let's see if we get that, because if I add 81.7 to 18.3, I should get 100. Let's see if we get that. I get 8.064 grams of hydrogen that we got, divided by the molar mass of 44.094 grams per mole, times 100. Let's see if I get 18.3. Boom, I get 18.3% exactly. So we just did 2 examples. To check your understanding, why don't you try and do example number 3 on your own, and we're going to pick up with example number 3 in class. Hopefully this was your beginning understanding of how to do percent composition given a formula by calculating molar masses and masses of each element.